So we're going to talk about solving systems of equations, and hopefully you remember some of this from Algebra 1, Algebra 2, and actually maybe even 8th grade math, possibly 7th as well. So anyway, we're solving systems of equations, and these can be different types of equations. They can be linear, they can be exponential, they can be quadratic, they can even be circles, different types of equations. So let's take a look at example number 1 and see what types of equations they are. A total of $25,000 is invested in two funds paying 7% and 4% simple interest. So this is not an exponential equation because it's just simple interest. The yearly interest is $1,405. How much is invested at each rate? So we're going to let X be the amount that was invested at the 7%, and we'll say Y is the amount that was invested at 4%. Okay, and so we know that the total amount invested was 25,000. So our first equation is just the sum of those two amounts is 25,000. Okay, and then we also know that the total interest rate for the whole year was 1,405, and to get that interest, we're just going to multiply the interest rate, so 0.07x, because that was 7%, and then 0.04 y, because that's 4% as a decimal. And then you can go about solving this in a variety of ways. I'm going to show you elimination. So you could use substitution. You might remember that. But I'm going to use elimination. So I'm going to multiply my first equation by negative 0.07. So what that makes that become is negative 0.07, or 7/100 x, minus 0.07y, or negative 7/100 y. And then when we multiply 25,000 times negative 0.07, we end up with negative 1,750. And so now we have our two equations where we can eliminate the x's. That's why it's called the elimination method. And so then we're just going to add straight down. So we end up with negative 0.03y equals negative 345. And so then we can divide both sides by your negative 0.03. And so we know that the amount invested at 4% was $11,500. And that was the amount at 4%. And then you can just plug that y back into either of the original equations. I personally think the first one is easier, so I would plug it back in right here. And when you do that, you end up with x is $13,500, and that was at the 7%. And so that is your answer. And you can check that answer by plugging both of the values back into both equations and making sure it works. You could also graph it. That's how you can find how much was invested at each rate. And keep in mind, those were both linear equations. All right, so let's take a look at example 2. Now we can see right off the bat that they are not both linear. The first one is quadratic. The second one is linear though. And so the first thing I'm going to do is solve for y for both of them. So the first one becomes y equals negative 3x squared plus 2x, right? And then the second equation becomes y equals x minus 2. So those are our two equations. And again, there are multiple ways you could solve these. This one, you could graph it if you want. If you use the graphing calculator, you might not get the exact answers. So what I'm going to do is do some substitution here. And so since they both equal y, we can say that negative 3x squared plus 2x equals x minus 2. So we're just setting them equal to each other because they both equal y. And then we can get 0 on one side. So if I add my 3x squared to both sides, and then I'm going to subtract my 2x, and that ends up giving me 0 equals, and I'm going to put this in descending order, so positive 3x squared minus x minus 2. Okay, and then we can go ahead and factor that to find our zeros. And so we know 3 has to go in front of one set of parentheses and x has to go in the other because 3 is a prime number. And then we know that 2 and 1 are the only factors of 2, but we need to get that -1, the sum of -1. So I'm going to put my 2 here and my 1 here, because if I do that, if I make my 2 positive and my 1 negative, that's going to give me a negative 3x and a positive 2x. So that'll give me my negative x in the middle there. And so then you can just take those and set them each equal to 0 to get the x values. And so we subtract the 2 and divide by 3, so -2/3. And then we're going to add the 1 over, so we get 1. So those are our 2 x values. But remember, to solve the system, we need to plug that back in to get the y values. And so when you plug, you can plug it into either equation. It really doesn't matter. I would plug it in to the linear equation just because that's a little bit easier. So when you plug in the 1, you end up with 1 minus 2, which is -1. So there's your first ordered pair. And then when you plug in -2/3, well, -2/3 minus 2, which is also 6/3, you get -8/3. And so those are your 2 ordered pairs. Again, plug those back in to the original equations, and that will help you to check. Also, if you were to graph this, it would look something like this. So we know that our quadratic equation would have its vertex there at 0, 0. Okay, correction, that is not at 0, 0, that the vertex. It's actually shifted a little bit over. So I'm just going to sketch the graph. You can graph it on your calculator if you want, but it's going to look something like that. So it's a little bit wider looking, and that looks like the vertex is at 0, 0, but it's really not. It should be shifted over to the right a little bit. So your parabola is going to look something like that, and then your linear equation is going to look something like that. And again, you can graph those on the calculator to see that a little bit better. You can also make a table of values to see, but then you can see your 2 intersection points. You've got 1, -1 there, and then your -2/3, -8/3, and I didn't do a very good job of drawing that, but it's just a sketch. All right, let's take a look at the last problem. Example 3, a small business has an initial investment of $6,000. The unit cost of the product is $23.20, and the selling price is $35.20. How many units must be sold to break even? So we know that our total cost is equal to the cost per bottle, which is $23.20, times the number of bottles, so that's N because that's what we're trying to find, plus the initial cost, which was $6,000. So that's the total cost, because you have to pay that $6,000 and you have to pay $23.20 for each of the units. And then our total revenue, that's the amount of money coming in, not profit, but total revenue, all the money coming in, is the price, the selling price per bottle times the number of bottles. So again, that's N. And that gives us the total amount of money coming in from selling that product. And so the break-even point is when your total cost and your total revenue are the same. So all you have to do is set those equal to each other. Now there are other ways of solving this problem, and that's totally fine. I'm just showing you, using two linear equations and substitution. Okay, and so then we can subtract the $23.20 times n. And you end up with 6,000 equals 12n. And then you can divide both sides by 12. So 500 units must be sold. N is 500. All right, and that is the end of this lesson.